Okay, so today we're going to be doing curve sketching rational functions practice. So we're going to be solving for the vertical asymptote, the horizontal asymptote, the x-intercept, the y-intercept, the critical points, the POI, the behavior on the VA, and the sketch and graph. And we're going to be solving for curve sketching rational functions. Okay, so sketch h of x equals 10x plus 2 over 2x minus 1. First of all, rational functions is h of x equals f of x over g of x, so it's two polynomials and one is over the other. And we have our checklist here, so we have vertical asymptote, horizontal asymptote, x-intercept, y-intercept, critical points, POI, behavior and the VA, summary, and then we have our sketch. So for vertical asymptotes, it's the zeros of the denominator. Set the denominator equal to 0 and solve for x. So our vertical asymptote is x equals a half. That means there's going to be a dotted line on the x value of a half. So next we have the horizontal asymptote. And for the horizontal asymptote, there are three cases. First case, the degree of the numerator, f of x, is greater than the degree of the denominator. In that case, the horizontal asymptote would be y equals 0. The second case would be the degree of the f of x, or the numerator, is equal to the degree of the denominator, g of x. Then the horizontal asymptote would be the leading coefficient would be y equals the leading coefficient of the numerator of f of x over the leading coefficient of the denominator, g of x. And then our third case would be the degree of the numerator, or f of x, is greater than the degree of the denominator, or g of x. Then there's no horizontal asymptote but an oblique asymptote, and we would use long division to get that oblique asymptote. In fact, we would do the denominator divided with the numerator here, and then we would get an oblique asymptote here. So if your question states that the degree of the numerator is greater than the degree of the denominator, then you would divide the numerator with the denominator and get an oblique asymptote on the top. So that's for case number 3. And then we look at our function h of x equals 10x plus 2 over 2x minus 1. And as you can see here, the degree just means the exponent, like the highest exponent of x, and whether that be on the top or the bottom. So I see here that I have an x to the power of 1 and an x to the power of 1, and that's all I see. So that means that the degree of the numerator is the degree of the numerator is equal to the degree of the denominator. Which means that the horizontal asymptote would be the leading coefficient of numerator over the leading coefficient of the denominator. And this is f of x, and this is g of x, if you prefer to look at it as f of x over g of x for h of x a rational function, or if you prefer to look at it as the numerator or the denominator. So it's the leading coefficient, which is 10 over 2. 2 goes into 2 once, 2 goes into 10 5 times, so it's 5 over 1, which would be 5. So the HA would be y equals 5. So for the x-intercepts are the zeros of the numerator. So set the numerator equal to 0 and solve for x. So as I said before, the x-intercepts are the zeros of a numerator, so set the numerator equal to 0 and solve for x. So 2 goes into 2 goes into -2 -1 times, and 2 goes into 10 5 times. So we have a y-intercept, so substitute x equals 0 into h of x, or the entire rational function, to get the y value of the y-intercept. And note that the x value of the y-intercept is always 0. So the y-intercept would be in brackets 0, comma, -2. And the x-intercept would be -1 over 5, comma, 0. So we have the x-intercept and the y-intercept. So we have critical points. So there are often no solutions due to the solving for x with the derivative not being possible. We're going to use the quotient rule to find the first derivative. We need the derivative for the behavior around the VA. So g of x is 2x minus 1, so we're going to put that right here and right here. F of x is 10x plus 2, so 10x plus 2 would go here. And then the derivative of f of x is just 10, using the power rule with the 10x and the constant rule involving derivatives with the plus 2. And then the derivative of g of x, which is 2x minus 1, and the derivative of that would be 2. And then we multiply out. We have 20x minus 20x, so those cancel out. And then we have negative 10 subtract 4. And in order to find critical points, we need to set it equal to 0 and solve for x. But there's no way to possibly do that. Yeah. So the answer is no solutions or critical points because you can't solve for x with the derivative that we found. So no solutions is actually quite common with rational functions, but moving on to points of inflection. So we have points of inflection. So again, there's often no solutions due to solving x with the second derivative not being possible. So we're going to use the quotient rule or the chain rule to find the second derivative. And we find the second derivative by taking the derivative of the first derivative. And we need the second derivative for the behavior on the VA chart. So there's our second derivative. And again, when we set this derivative equal to 0, there are no solutions. So there are no solutions or points of inflections for this rational function question. And then we're moving on to behavior on the VA. So with behavior on the VA, it's similar to the chart of concavity and increasing or decreasing intervals. So again, we're going to need the VA. We're going to need the first derivative. And we're going to need the second derivative. And then we're going to make a chart. So the first derivative and the second derivative. And the VA is x equals a half. And then we're going to choose numbers above and below the VA. So we're going to choose 0 and 1. And then we're going to input those numbers. We are going to input into the first and second derivative. First derivative for increase or decreasing, for increasing or decreasing. Second derivative for concave up and concave down. Or for concavity. And okay, so positive is for increasing and concave up, and negative is for decreasing and concave down. So the second derivative is for concavity, the first derivative is for increasing or decreasing, and we input those numbers, these numbers, into the first and second derivative in order to figure out if it's increasing, decreasing, concave up, concave down. And we're going to use symbols like the down arrow, the up arrow, the and then these symbols as well to indicate if it's concave up, concave down, concave up, concave down, increasing or decreasing. So I hope that was informative, and that's what we will be doing today. I've left this up so you can write it down. There. Okay, so this will be so as you can see here, it is decreasing. Because it is negative. So it is decreasing before the VA and after the VA. Okay, so before the VA, it is concave down, and then after the VA, it is concave up. So, and now we have our summary. And then we have our function there. So there's our x-intercept, and here's our y-intercept. And there, now it's graphed. You can highlight it if you want to. There you go. So it's the first rational question, and it's graphed to completion. If you'd like, we can label the x-intercept and the y-intercept. There, now all the points are labeled. And that'll be everything for today. Thank you very much and have a great day.